Hey, good morning, everyone. Welcome to the webinar for Altair Inspire Cast. My name is Rama Annamraju. I'm an applications engineer here at TrueInsight. Let's go over a quick introduction. So I'm an applications engineer here at TrueInsight. I've been working here for almost 5 months now, so I'm relatively new. But I've been working as a design engineer, research engineer in multiple industries, including the oil and gas industry, academic research industry, and medical device industries. I have a master's degree from the Tennessee State University, class of 2019, and I'd love to travel, and I love making tech videos and studying about tech, all kinds of. So let's have a quick intro about what is TrueInsight and what is Altair Inspire Cast. So Altair Engineering is a software company that provides engineers with better products that will help them design and analyze the products that they're designing. So Altair transforms design and decision making by applying simulation, machine learning, and optimization throughout the product life cycles. And TrueInsight is a premium channel partner for Altair Engineering. So we cater to from the startup industry to the medium business industry, and we provide all kinds of support, tutorials, technical presentations, and everything. So let's go over the agenda of this meeting. So we will discuss about what is InspireCast, why customers would choose InspireCast, then go over the geometry creation capabilities or the USPs, and then we will delve into the supported processes. Then we'll discuss some options, and then we'll go over a demonstration, and finally we'll have a Q&A. Although as always, just feel free to ask any questions in the chat window. I have my colleagues Tyler and Drew, and they can answer all questions. Moving forward. What is InspireCast? So InspireCast is a fast and easy, accurate, and affordable software tool. It is the only tool that caters to beginners and experts alike. So it caters from product designers to foundry engineers. Its simulation environment focuses on creating high quality components with increased profitability. Its guided process templates ensure a flat learning curve. So it's easy to learn and fast to implement. Users can avoid typical casting defects, such as air entrapment, shrinkage porosity, cold shuts, mold degradation, and more by using InspireCast software. InspireCast offers 5 easy steps to simulate gravity die casting, gravity sand casting, investment casting, high pressure and low pressure die casting, and tilt pouring. So why do customers choose InspireCast? So it's comprehensive simulation-driven design environment to manufacture high-quality metal castings. It is the fastest growing casting simulation on the market. Quick ramp up requiring minimal training. So you don't need any high-end trainings to start and do qualitative simulations. The part of compelling and patent licensing model with access to entire suite of tools. That is, including with InspireCast, you have other suite of tools that you can access to better design your products. So what are the capabilities or the USPs of InspireCast? So it has an intuitive interface to create rigging components for casting. It has one-click geometry generation for cores and molds. The auto creation of risers with full control of on-screen manipulation of sizes. Guided templates for most casting process simulation. So InspireCast solver uses parallel processing, which enables a significant reduction in calculation time. That saves money. Most parts can be solved in minutes on a regular workstation. Since InspireCast uses biphasic air metal model for computation, the effect of air when filling the mold is better captured to predict the air entrapment, if that's what you're looking for. So what are the InspireCast supported processes? So we have gravity casting, we have high pressure die casting, And then we have the low pressure die casting, the investment casting, and tilt pouring. Let's move forward and look into the 5-step simulation process. So we have these 5 steps that you can perform to do any type of casting that we have mentioned above. So let's go over it real quick. The first step is selecting a part and the gravity direction. So as you can see, it's just a couple of clicks away. You select the part and select the gravity direction, and you have on-screen controls to update anything. And then you define the gates. So you have 2 ways to define the gates. Either you add a gate to a existing surface, or you model an existing gate or a runner system and assign that particular part or component as the runner. Then you can go to components and create or import different types of components, like the molds, like the cooler system in this case. Next, the setup process is simple as well. So it's just 1 click away. You go to the setup process, what type of setup that you want to do, whether it's gravity casting, high pressure casting, or low pressure casting. You just select the appropriate option, and then you select either the filling time or you have the filling velocity, different parameters. And then you just move forward for the run or analysis results. So this is where it gets really interesting. So in the run window, once you open it, you have multiple options to customize the way you run the simulation. You can even go for advanced meshing using our advanced tools like SimLab. So once you've done your analysis, what's the result visualization would be like? So you have 2 types of analysis that you can run. One is filling analysis and another one is solidification analysis. So here you have in the left a table that can depict what all kinds of results that you can capture from this analysis. As you can see, you have a wide variety of results that you can see from here. So coming to the options. So what kind of flexibility that does Inspire Cast give the engineers? So number 1, importing geometries. Inspire Cast does not restrict the engineers to design in a specific software. You can import from all different softwares natively into Inspire Cast. In the same way, you can even export into different types of file formats and use them in other softwares as well. For help options, there are 3 ways. Number 1, you can just hover on any icon and press F1 to get an online help. Number 2, you can access tutorials right from the software. Just go to File, Help, and Tutorials. You'll have tutorials with step-by-step directions to practice the type of casting that you're doing. And number 3 is you can always connect to an applications engineer like myself or Drew at TrueInsight. We will always be there for you to help you guys out, whether it be technical or any kind of other support related to the software. And the final one is kind of the most important one, is that customization. What kind of customization does Inspire Cast provide you guys? So number 1 is that you can go to File and Preferences to access various customization options. In there, you can update your frame rate for video capture. As you've seen a couple of videos in the previous slides of this presentation. So you can just capture videos right from the software itself, number 1. And number 2, you can just adjust the frame rate so that when you're presenting to the customer, you can have a high frame rate video and then show them what's going on with the filling or whatever analysis that you're doing. Number 2 is the mouse controls. You can set your preferred CAD tool as a default mouse option. So different CAD tools have different mouse click options. Some have the right click as a pan, but others have right click as zoom. So different options can be set. The other one is you can customize your analysis options, like the core count and mesh settings. These are advanced settings where, once you keep on going and, keep on going with the software, and once you start doing really complex simulations, you can adjust the analysis settings as well. And then you can import and have a PDM interface. So you can have multiple people working on the same component at a time. You can also set standard materials or download material database from Altair One Marketplace. So you can have custom materials added into your suite of software. So advanced meshing, like I said, can be performed using the high-end tool SimLab. Let's jump on to Inspire Cast for a quick demonstration. So this is the Inspire Cast graphic user interface. So you have multiple sections over here. Right in the middle, like any other software, you have the graphics user interface. This is where you interact with your models. On the top, you have the menu bar. And on the bottom left, you have the view editor. And on the bottom right corner, you have the unit selector. Right next to the unit selector, this is something called as the snap filter, where you can actually snap your mouse pointer onto the grid. I'll show it to you in a while. So let's go to the menu bar real quick. So in here, let's open a tutorial file. I go to help and then click on tutorials. Then this is how you can see the tutorials. There's the help menu where you can see multiple tutorials. Let's open gravity casting. So in the gravity casting tutorial, you can see there's a step-by-step description of how you can perform this particular casting. Let's minimize this and start the tutorial. So let me open a tutorial. You can access the tutorials from the installation folder. Just go to Program Files, Altair, the current version of Altair, and you can see Inspire Cast. And there you can see tutorial models, and you have them included right in the installation. Let's open the gravity casting model. So this is a brake caliper. And before we start performing the analysis, let's go over the menu bar real quick. So in the view, you can actually go and select model browser. That'll give you a model browser where you can edit the model. You can also view the property editor, where once you select the model, you can see the different properties of this model. Once I select a material for this, it'll even populate the mass and the volume of this model. Let's go ahead and start the process. So remember I said a 5-step process, right? So let's start with the first step. I select the cast part, okay? Now, once we select the cast part, once we hover the mouse on the cast part, it'll just highlight the cast part. And this is called the micro dialog. Using this micro dialog, you can select what type of material this cast part needs to be. So for now, let's keep it the default material. However, as you see, we have this material, alloy that has different sections over here. We can edit the material types right from the micro dialog. Once you click on this, you have a new window opening up where you can add materials or you can edit the materials. You can also change the standard of materials that are represented in here. Let's change it to ASTM and select. There you go, you have the material standard changed. So once I select the material that I want, I just click the right mouse button and swipe left to select it. As you can see, Inspire Cast has assigned the component as cast part. So once I assign the cast part, the next step is to select the gravity, right? So let's go to click on gravity, and by default, the gravity is shown as negative Z direction. So I want to, let's say, manipulate it. So on the micro dialog box, I just click on rotate the model. And now I just get options to rotate the model. Okay, I can rotate it by 90 degrees. That sounds good. So again, I right click and swipe left. So now I have selected the gravity as well. The next step is to select the gate. So in here, we have two options. One is either designate surfaces as gates or create or edit gates. In this case, I'll just add a gate. So once I click on add a gate, I can just hover my mouse on any surface and it'll show me a gate over there. So once I hover the mouse and click on that surface, it has created a gate over here, right? So let's change some parameters over here. And then, just for fun, let's rotate the gate by 20 degrees. Okay, once that is done, I'll extend the length of the gate. Once I'm happy with my inputs, I'll just right click and swipe left. So now I have the gate added. The next step is to add components. So in this case, all I need is mold and the core. So first I'll add a core. As you can see, once I click on the core, the software automatically identifies features where we can add core. So I just have to select that feature. And then we have a micro dialog box selecting what kind of core it is. For now, I'll just keep it default. There you have, we have the core added. Now, once we have the core added, let's create a mold. So as you can see, it will just visualize a transparent mold around the component. And in the micro dialog box, we have the selections. Let's select the mold as silica sand and keep the standard temperature and everything. So right click and swipe left, select. So once you've selected the mold and you've entered it, you can see that the mold disappeared. So it is Inspire Cast. What it does is that once the mold is created, it'll hide so that we can visualize and we can see the component. So if you actually export this file as it is now into a step file, you will have the mold as a separate component as well. You have the mold, you have the core and everything. You have the in-gate as well. So Inspire Cast is actually creating components, dynamically. That is the best part over here. And once we move on to the next part, we just go to the basic setup. So in the basic setup parameters, we have two options. Number one is initial velocity, or you can even enter the filling time. So I'll keep the filling time. I'll select the filling time and keep it as the default right now. So to enter it, right click and swipe left. So once I have the parameters set, now all I need to do is analyze. So we can just click on the play button over here to run the analysis. So in here, we have different options. One is you can edit the average thickness of the element size over here, or you can select in the element size that you want in the component. For now, I'll just keep the average thickness. And this is populated automatically. You can even edit it later on. And you have two analysis types. We have filling analysis and solidification analysis. In the advanced features, you have the mesh control features. So if you click on use advanced meshing with SimLab, Inspire Cast will open this model in SimLab. And then inside SimLab, you can just refine your mesh however you want, and then come back right into Inspire Cast and run the analysis. So for now, let's go ahead and run both filling and solidification analysis. And as you can see, Inspire Cast automatically meshes and does the analysis. So it saves a lot of time with meshing and pre-processing, which are the two most time-consuming and resource-intensive tasks in any simulation software. So once we have the analysis run, we'll have the multiple result types that we can analyze from. Before we go over there, I'll just go ahead and explain additional features of Inspire Cast. So it is typical in the industry to first design a process and then simulate it, but Inspire Cast turns that concept over its head by helping users evolve the process in tandem with their ideas. You can start the filling with virtualized in-gates like I showed, and that will guide you through the areas of porosity and the right risers to compensate. So the radical new designs in combination with new materials demand designers to evaluate their designs early. So Inspire Cast enables engineers to engage early with to simulate possible issues upfront with minimal or no training. And key features include, again, ease of use with 5 simple steps. You can use a variety of casting templates to simulate. You can optimize the in-gate design and position. You can validate full casting designs. So the computation is faster than ever, and it's an accurate solution. While I was giving you all this information, you can see that Inspire Cast is already done meshing. It is doing the filling analysis. While it is running, let me pull up an existing test results. So this is the same test that we performed right now, but the results visualized. So we have 2 types of results over here. Number 1 is the filling. Number 2 is solidification. Let's look into filling objectively. So in the filling analysis, we have multiple result types. And let's say we look into the temperature. So using this result, we can view how the temperature changes during the filling process. By doing so, you can determine the temperature required for 2 fronts of material to fuse and study the risks of cold welding. And additional to that, we have other results that can populate what types of simulation that we are trying to, what types of results that we are trying to visualize. You can see that the flow front is smooth and simple. Let's go ahead and see flow front. So flow front is another useful result. Using this, we can observe how the material behaves as it enters the mold. So you can predict filling time. Another type of result is cold shuts. So cold shuts, usually using this, you can examine where 2 fronts of material meet and what the temperature difference is. If you observe in here, cold shuts are indicated in the rainbow pattern. So as we zoom in, we did find a cold shut in this model. So that will allow me as the foundry engineer or the design engineer to tweak the design or maybe make changes in the analysis or the filling time or the velocity to make sure that I don't have cold shuts. Another type of analysis result type is solidification, right? So let's go ahead and look into what type of solidification results we have. So just like filling analysis, we have all different types of results in solidification as well, including temperature, solid fraction, and everything. Let's look into porosity. So porosity, again, Inspire Cast shows you the shrinkage related porosity, and it is caused by sections of casting that solidifies later than the surrounding sections. And as you can see, we have porosity occurring inside this model. So this type of visualization will help me understand better about the design and will help me design better components. Once we have the porosity, let's look into solid fraction, because that is something related to porosity as well, right? So in this result, we can view the last areas to solidify, and it will allow me to predict the shrinkage porosity. And it's just kind of more likely to occur in isolated areas, right? So once I click the play button, so it'll show us again on the legend itself that you can change the solid fraction value. By default, the solid fraction value is set at 0.7, and in most cases, it corresponds to the value at which the liquid stops flowing. Again, in the animation, the solidified material is transparent, while the liquid material is shown colored. There you go. So Let's look at one final result type. Let's look at mold temperature. There you go. So you can visualize the mold temperature results, and this will provide you with valuable information to help you create and validate the design of cooling channels, if anything is necessary. So we can see the temperature changes in the mold during the solidification process. Mold temperatures will help you determine temperature differences between different components. Example, the part, the core, or the sleeves. So now that we have seen different kinds of some examples of the result types in the analysis, let's look at other options. Let's say we look into callouts. So we have the callouts button over here to call out what kind of temperature at different locations we have, either the temperature, if that is selected, or different kinds of results. Right? So we can also use the min and max to see where the minimum and maximum changes of that particular criteria we're looking at. Let's say in this case, minimum and maximum temperature. If we change it to microporosity, where we have the minimum and maximum microporosity occurring. We can even do a plot using these callouts. Right? So once we click on the plot, what it'll show is that it'll create, by creating callouts automatically, the callouts will automatically plot those points on a graph depicting the result type over the time. So each line on the graph corresponds to a numbered callout. Here we have a graph. So we have multiple callouts over here. Let's say the temperature. Okay, so depending on different callouts that I have mentioned, so this is the temperature variation that is occurring. So now we have seen how Inspire Cast works. Let's kind of segue into the options and see how we can actually customize our Inspire Cast. So this is the customization I was talking about. So we can have different types of preferences set over here. Let's say, for example, we have the mouse controls. Like I said, we have presets where you can select different types of CAD tools by default, and you can just apply them, and the mouse controls will adapt to that particular mouse control. You can have analysis results. You can, in the analysis setup, you can go to advanced setup where you can select different cores depending on what kind of CPU you're running on. If you're running really complex simulations or parallel simulations, you can update these criteria to make sure you have the best results possible. So this is a quick demo of Inspire Cast. Let's see if we have any questions in the chat that we can answer.
There's no current questions, Rama. There's one question by Jim. But yes, this recording will be available.
Yes. So I do have another question that says, why do we need to specify the core? So basically, cores are something that you define when you have sand that is not, when you have features in the model that the mold cannot penetrate into. In this case, for example, let's say we have a mold that opens right in the center, right over here, right? So we cannot have components that are penetrating into it. So, and this is a big hole. So let's say if you want to say that, hey, that's okay, I will create the mold with material over here, then you have to machine that particular material out. So that's additional step for the post-processing. So in order to avoid that, both machining for post-processing and wastage of material, we add cores. That is good to know. Yes, so the core material, as you can see, it need not be similar to the mold material, but in most cases, it is similar to the mold material because core is something that you just pull it out after the casting is done. You're welcome. Any more questions? You're welcome, guys. We'll have another couple of minutes for questions.
Yeah, there's a few more questions coming in, Rama. So one question on training, and then another question about optimum location of gates.
So Inspire Cast will not suggest you optimum location of gates by itself directly, but using the results, we can actually predict the optimum location of gates. So let's say for solidification, we can see that, okay, solidification time and see, okay, what time it is taking. And maybe if I can change the gate to a different location, then the solidification time will get better. So we have to use the results that the software is showing us to update the gates. The reason why it is not suggesting gate is because casting is a complex study where you can make different types of materials, different types of components in different types of ways. There are n number of ways to do the same component. So that means suggesting something really specific is more like restricting the engineers, flexibility. So you have different types of material. Let's say if you go to core, you have different types of material by default added to Inspire Cast and their alloys as well. However, you can go into the material library, see, and you can import or export the material. You can add materials over here. You can just create a new material group and export it out to a different software, or you can import a material group as well. For now, yes, we have metal alloys only in here in the default. We, you can always download additional material libraries from Altair One website, which I will show you in a short while. And Anthony, I guess Drew answered your question, right? Okay. So yes, for the training, you can utilize us as applications engineers to give you guys some basic trainings. You also have webinars like this that can go over from beginners level to medium expert level, where you can understand how to use the software. What's the other question? So yes, thank you, Drew, for answering that. And let me show you, while Drew is answering that, let me show you Altair One. So this is the Altair One website. So you download the software using this website. You can access support using this website. You can download resources using this website. You can do all kinds of different ones, different tasks using this website. As you can see, the tools in here are segregated. Actually, they are segregated into different areas of expertise. Let's say if you're an electronics engineer, or you're a mechanical engineer, you can just filter the tools that we provide by mechanical engineers applications, and then you can just you can download that particular software. In this case, let's go to Inspire Cast. So once I click on Inspire Cast, I have different options where I have the intro. Then in the download, I can download the software itself and other related downloads. I can even download the documents that are linked with Inspire Cast, whether it be release notes or anything. Looking into the license manager, you can control your licenses using this, and it brings us to the point where how does Inspire Cast or Altair software calculate licenses? Altair does not restrict license per use. They actually control the licenses per the solver or per the software that is being used. You can always reach out to one of our representatives to understand more about licenses, but again, it's interesting. And we are always ahead of the competition in terms of license management. And in Altair One, you can access community and support, marketplace, all kind of different help as well. And in the Learning Center, you can go ahead and look up for webinars, or you can just reach out to blogs, read any issues and everything. And similarly, at TrueInsight, the channel partner for Altair, we are also always providing more and more content in our website. So we work with Altair in tandem to produce more helpful content for the customers. We have a YouTube channel that puts out more and more videos like this. This webinar will be on our YouTube channel as well, so you can review it anytime later on. So we have multiple things that are useful and helpful for the customers. That is great. Great questions, guys. I really appreciate you guys actively participating in this. So we'll have 3 more minutes before we hop off. There's other tools as well. Yes, before we drop off, there's something that I want to show you guys is right in Inspire Cast, you can just sketch and manipulate the geometry. You can fix or patch the geometry errors in here directly. So you need not go back to a different CAD tool to design your geometry and come over here to analyze it. You can just start your geometry sketching over here, start sketching right over here, and then go ahead and do your analysis. Let's say you start a new sketch. It's simple as any other tool. So like I said, the snap filter is something where, let's say if I'm trying to draw, it just snaps onto the grid over here. And you can edit the grid in the preferences as well. So let's say if this current grid is like 9 millimeters. So you can edit the size of the grid. So you can just do all kinds of stuff right in here in the software. So yes, that concludes our presentation, guys. And thank you for joining in, and thank you for all the interesting questions. If you guys have any more questions, always, feel free to go ahead and visit TrueInsight.io, and also visit our YouTube channel, youtube.com/TrueInsight, where you'll find interesting, information and technical information as well. Please do feel free to subscribe so that you'll be notified of this presentation and other webinars and presentations as well. Thank you for joining in, and I really appreciate it. Have a great rest of your week.